All right, so let's take a look at number 2. Number 2 said, it says, so it's the directions where write a compound inequality that represents a situation, graph it. All right, so what they said is all real numbers, so that just means any value. That means any value for x that meets this qualification. So it's all real numbers that are at least 2 and at most 9. So these are my limitations. That 2 is my minimum that my x's can possibly be. My x is my maximum that all my x's can possibly be. All real numbers means just any x value that is meeting this qualification. All right, so I have a minimum of 2. At least means that it can include 2. So that means my x is greater than or equal to that 2. And, I'm just going to write and here, that x is less than or equal to the 9. So if I wrote these 2 individually, that's what it would look like if I wrote this individual ones. My x's, all x's that are greater than or equal to 2, and all my x's that are less than or equal to 9. All right, but for ands, we put these 2 together. So it's 2 is less than or equal to x, which is less than or equal to 9. There's nothing to solve, though. Yep, so there's nothing to solve. It was just writing the inequality solution. All right, what else can I do for you guys from the homework? Isabella? All right, let's take a look at 11. So, as I said to a couple people on these, you still have to pay attention to your inequality rules when we're solving. Number 11 is a really good example of that. So I have negative 16 is less than negative 3x plus 8, which is less than negative 7. Is this the one you're talking about? Okay. Andrew, you have your marking pen in your hand. You guys all are paying attention to this, making any corrections that you need to, please. So I know that this can be confusing, so if it helps you to be like, how do I start? Just block off that right-hand side. Everyone look up at the board. Everyone's eyes on the board. Block off that less than 9, or less than negative 7 here, and say, what would I do to start solving this? Well, what would I do to start solving this? Serena? Excellent. I'm going to add a negative 8. Now remember, I'm doing it to all 3 sides. So now it's not just to those 2 sides here, not just the negative 16 and not just the negative 3x plus 8. It's we're adding it to the negative 7 as well. So we end up with a negative 24 is less than a negative 3x, which is less than a negative 15. Okay, so now, if you're not sure what to do, block off that right side part. What am I going to do to get my x alone here? Come on. Matthew? Yep. Excellent. I'm going to divide by negative 3 on all sides. What happens to my inequality symbols since I'm dividing by a negative 3? Peter? They flip. So these less than all of a sudden become greater than. That is the only time you are changing the inequality symbols, is when you are dividing by a negative coefficient or multiplying by a negative coefficient. So now I'm going to do my math. Don't forget, that is a negative 3, so put the negative with it, please. So negative 24 divided by a negative 3. Chris, what is a negative 24 divided by a negative 3? Yeah, you do have to pay attention to what we're doing. So what's a negative 24 divided by a negative 3, Chris? 8. And then in the center, I just have my x. Peter, what's a negative 15 divided by a negative 3? Okay. That's okay. You have to pay attention to what you're doing. Here's my solution. However, it needs to be written as least to greatest. So when you are rewriting this, be careful. So my smaller number is the 5. I have the less than, I have the small side of my inequality facing the 5. So 5 is less than x, which is less than 8. This is the proper way to write it. Get used to doing that, please. If on a quiz or a test you write it this way and you make a mistake writing it back this way, I'll take that in consideration only because you did it right. Sometimes it's hard flipping it. What else can I do? All right, let's take a look at number 44. 44 was tricky. All right, so you have to kind of pay attention to how to set these up and how to make what we have work for how to set it up. So what they tell us is the force exerted on a spring is proportional to the distance the spring stretches from its relaxed position. Suppose you stretch a spring d inches by applying a force F in pounds. All right, so they're telling us that we're stretching a spring. All right, d is going to represent the number of inches you stretch the spring. Right? And then they tell us that F is the force you apply to stretch it. I cannot impress on you enough the importance of understanding what the variables stand for in these equations, these formulas. Chris, you're paying attention to what we're doing? Dude, you better not be falling asleep over there. Because I have a sneaking suspicion with your back to me and your hand in your head, you're falling asleep. So take your hand off your head. All right, so what they've told us is they have said d over f is equal to 0.8. There's the formula that they have given me. All right, so what we want to do is, what they say is you apply forces between 25 and 40 pounds. So these are our maximum and minimum force. That's what that is, our maximum and minimum force. So we want to know, write an inequality that describes the stretch of the spring. So what we want to do is we want to find the possible distances it stretches. All right, so here's the deal. They have given us a minimum and maximum force. How many of you guys recognize that? All right, so I'm going to start with that game plan. I have my minimum force. Everybody should have this game plan. If you did not write this general game plan down, you're doing it now. Some of you did a really nice job writing this. Make sure you're writing this, because this is the key to this. The minimum force, it says it's between these two, but it doesn't say it's necessarily including them, although in theirs they say it is, so we'll go with it is. So minimum force is less or equal to our actual force, which is less or equal to our maximum force. How many of you guys are cool with that very general game plan? Okay. So this actual force is F. So what I need to do is, I need to write an equation for force. It needs to be force equals something. All right. Well, they've given us d over f is equal to 0.8. I need to solve this formula for f. I cannot put that into here because this is not solved for f. All right, so I've run out of room. So I have d over f is equal to 0.8. How can I start solving this equation for f? Remember, we did a whole section on rearranging the formulas and solving for different variables and formulas. So I need to get f alone in the numerator. How am I going to do that? Peter? Not d. I'm going to leave d there. I don't want to multiply everything by d. I need f in my numerator. Serena? No, I don't know where 25 comes from. No. I'm not putting in my minimum and putting in my maximum to come up with whatever my values are. I'm writing an inequality statement for this. Can't I multiply everything by f over 1? How many of you guys agree with that? Everyone's eyes are on the board. You're doing this now because I'm giving you this on a test. So I need to get f in my numerator. I need to solve for f. Because I need an equation f equals something to put into my game plan. So I need to get rid of f in my denominator and get it up in my numerator. So I'm multiplying everything by f. So I end up with d is equal to 0.8 times f. Now what? I need to get f alone. Now what? Charlotte? Yes, I'm going to divide each side by 0.8. So I end up with f is equal to d over 0.8. Now I have my equation for force. So remember, we have minimum force is less than or equal to my actual force. This is where this formula is going to go into, is for my actual, which is less than or equal to my maximum force. Because this actual force is my f. And my equation for force is d over 0.8. So I end up with my minimum is 25 pounds, is less than or equal to d over 0.8, which is less than or equal to my 40 pounds. And now I solve that. So the key to this is understanding you need to put in an equation. Because this is minimum maximum force, I have to put an equation that equals force in there. All right, you definitely are going to have story problems like this, so I need you guys to understand how these are set up. I'm going to try and find some worksheets that are going to help us practice these more before we move on to the next section. All right, but we are going to be talking about ORs today. Is there anything else from this homework that we can go over? All right, so I am going to find more story problems to help us with this, so you guys can have more reinforcing of this week. All right, but for now, put this away, get your notes out. We need to talk about ORs. Fix it. Fix it. No, there was nothing else that needed to be fixed. That is correct. Nobody gets to leave their stuff out wherever they want. You guys all put it inside your desks, please. Thank you. All right, so we have 3.5 continued. All right, we're talking about compound inequalities. We're talking about OR today. Or let's review ands for a second. When we have an and, it's going to look something like negative 8 is less than or equal to 2x, which is less than or equal to 10. All right, so this is what an and looks like. I could write this, we're not going to see this often, but you could write this as negative 8 is less than or equal to 2x and 2x is less than or equal to 10. Technically, it could be written like that, but we typically don't see it that way. Just so you know, you could write that. We're going to divide all sides by that 2. It's a positive 2. Everyone's taking notes on this, please. It's a positive 2, so I don't flip my inequality. And I have negative 4 is less than or equal to x, which is less than or equal to 5. So again, it's an and because we could say something like x is greater than or equal to negative 4 and x is less than or equal to 5. That is what that means. But we typically see them as a combined inequality. But that's what it means. It's all x's that are greater than or equal to negative 4 and less than or equal to 5. Yes. I didn't change it. No, I did not. Okay. What are you talking about? I didn't change anything. All I'm saying is this is what it should look like, but this is what it can mean also. These are the same thing. My x is greater than my negative 4, and my x is less than my positive 5. I don't understand your question. Okay. It is. Isn't x greater than negative 4 here? Isn't x greater than negative 4? I just changed the order because I wanted the x to come first when I wrote it. I don't want you writing it this way. I'm just saying that's what this means. Do you understand? Okay. So when we talk about ors, all right, when we talk about ors, the solution for an or is going to look something like, so if we did something like this, all real numbers that are less than negative 3 or greater than 7. If you notice in these, it has the or in it. And ones, like we had last night, have the ands in it. It's at least negative 2 and no more than 9. So there's an and in there. Here there's an or in there. All right, all real numbers just means all my possible x's. So what are the two inequality statements that I could write here that represent this? Serena? No, you start with x. X, not less than negative 3. Excellent. So there's what that solution is going to look like. X is less than negative 3 or x is greater than 7. All right. Now, these ors, so this is what the solution is going to look like. All right. If I was to graph this solution, all of you guys graph that solution, you have to have a ruler. Your number lines are going on grid lines. All of you should have a ruler out for this whole chapter. All right, you have these both individually. Almost every or are going to look like this, you guys. Look over here. Look over here. All your ors are, Chris, Peter, over here. Hey, all of your ors are going to look like that. You have a dot and it's going to be pointing one way, the other dot's going to be pointing the other. This is an or, that's an and. Do you guys understand the overlap? Ors go usually in different directions, okay? Just so you know from a visual standpoint. All right, so I have an open dot at my negative 3. And all my x's are less than my negative 3. The other start number is 7. I have an open dot at 7, and all my x's are bigger than 7 because the bigger side of the inequality is facing the x. So these are all the possible x values. All my possible x values are in those shaded areas. They're either less than -3 or they're greater than 7. All right, so that's what the solution is going to look like from a written standpoint and a graphing standpoint. So now let's solve some OR inequalities. So I want you to solve and graph. Now OR inequalities are two completely separate inequalities that we're going to put on the same graph. So when we have OR, these are two completely separate inequalities that we solve and graph on the same number line. So where an AND usually is one that is all like a three-sided one, all right, we could break it apart. If you guys don't like seeing the three-sided one for an AND, you can break it apart if you want. All right, but ANDs are a lot easier if you just kind of leave them all together. ORs will be completely separate. So let's solve something like 4v plus 3 is less than -5, or -2v plus 7 is less than 1. All right, first of all, these two inequality symbols do not need to be the same. They do not need to be the same. They are both completely individual from each other. All right, so I want you all to go ahead and solve both of these, please, and then graph your solution. So go ahead and do that right now, please. I'll do it while you're doing it. Don't forget, if you have a negative coefficient, when you divide by that negative coefficient or multiply that negative coefficient, you've got to flip the symbol. All right, for that second one, this is the work you should have had. All right, how do I graph that? How do I graph that? Chris? Okay. Okay. Excellent. To the left, right? Awesome. And then what? Excellent. That's exactly right. How many of you guys are cool with that? How many of you guys are like, yeah, that's pretty easy? Okay, now that you've done ands, ORs are a little bit easier, right? You guys cool with that? Okay, there's really not any story problems for ORs typically. I mean, in a higher math, you probably would get one, but for us, we're not going to have any OR story problems. All right, so your story problems are going to be ands, okay? You guys cool? Okay, you guys can go. Or you guys can pack up. We have a couple minutes before you can go.